Hi, welcome to Science 1206, the Weather Dynamics Unit. I'm Ms. Ledwell, and in this video, we'll talk about latent heat. Let's begin. Latent heat is the heat absorbed or released by a substance during a change in state without a change in temperature as the substance changes state. Latent heat appears as a plateau on a heating curve. So we'll see on this heating curve, we have a plateau here and a plateau here. This is latent heat. In this area of the graph, a change in state is occurring without a change in temperature. If you notice on the graph, the y-axis is temperature, so the plateau indicates that the temperature is not changing at these points. The latent heat of vaporization is the heat required to change a substance from a liquid to a gas. To transform liquid water into steam, water vapor for example, the molecules within the liquid must be pulled apart. As the change in state from a liquid to a gas takes place, the energy supplied is used to overcome the attractions holding the water molecules together, not to increase the temperature. Thus, as long as the liquid water is present, all the absorbed energy is dedicated to overcoming molecular attraction, keeping the water and steam's temperature constant at 100.0 degrees Celsius. The latent heat of fusion is the heat required to change a substance from a solid to a liquid. Energy is required to change water in a solid state, ice, into liquid water. As the change in state from a solid to a liquid takes place, the energy supplied is used to overcome attractive forces, not to increase the temperature. In a mixture of water and ice, the temperature of the water remains at the melting point of ice, 0.0 degrees Celsius, for as long as any ice remains. Now let's take a look at a heating curve. A heating curve is a graph of temperature versus time that can be used to summarize the changes in the state of a substance as energy in the form of heat is continually added. Notice here that the temperature does not change as the solid becomes a liquid. Notice at this point that the temperature does not change as the liquid becomes a gas. So these two areas appear as what we call plateaus on the graph. The first plateau represents the latent heat of fusion. Here, the energy in the form of heat is being used to overcome attractive forces, not to increase the temperature, and that is why we have a plateau. The second plateau represents the latent heat of vaporization. We're having a change from a liquid to a gas, and again, the energy in the form of heat is being used to overcome attractive forces, not to increase the temperature. The water cycle, as we know, plays a crucial role in Earth's climate, using latent heat to absorb and release energy during the evaporation of water at the equator and ice melting at the poles. The natural processes help regulate our planet's temperature, making Earth habitable for living organisms. Now it's time to review. Complete the lab investigation in Brightspace.